Our work focuses on the subpopulations of millisecond radio pulsars. Radio pulsars, rotation powered and primarily detected in radio frequencies, are the most common manifestations of neutron stars. The subgroup of these radio pulsars with spin period less than or equal to 20 milliseconds and understood to have been produced by processing in low mass X-ray binaries are known as millisecond pulsars. Their surface magnetic field assumed to be dipolar and estimated from their spin down rates range from 10^7 to 10^9 Gauss. Rotation powered MSPs appear in many different flavors. To begin with, they can be isolated or part of binary systems. On the other hand, they can be categorized depending upon their location in the galactic disk or in the globular clusters. Furthermore, based upon the electromagnetic emission spectrum, we may also segregate them as radio MSPs and high energy MSPs. In this work, MSPs for which no high energy higher than radio emission has been detected are categorized as radio MSPs, whereas MSPs with detected high energy emission has been categorized as high energy MSPs. Quite a few of these high energy MSPs have not been detected in the radio frequency band at all. This population table summarizes the characteristics of the above mentioned subpopulations of millisecond pulsars. It appears that high energy MSPs are primarily detected in the galactic disk.
Here, the intrinsic properties have been studied through histograms. We have also compared the subpopulations using the two-parameter Kolmogorov-Smirnov test with the null hypothesis that both the populations are drawn from the same underlying distribution. The p-value is the probabilistic measure for accepting the null hypothesis. If it happens to be less than the significance level of 0.05, then the null hypothesis is rejected. These are the cumulative distribution plots comparing various subpopulations. For both spin period and magnetic field, we see that the radio and high energy MSPs are very different. The same is true for the globular cluster and the galactic disk subpopulations.
Pulsars switch off when conditions for pair production fail to be met. Radio pulsar deadline is defined to be a relation between spin period and spin period derivative or spin period and magnetic field beyond which the process of pair production ceases and a pulsar stops emitting. Many theoretical deadlines have been suggested till now. Here we show two of these deadlines that are known to limit the radio pulsars population most effectively. It is noteworthy that the high energy MSPs cluster towards the smaller spin period region. It is clear that MSPs which are understood to be recycled through binary accretion are well above the deadline. However, J18013201 lies far below the extreme deadline.
To summarize, our inference from the present study is that the detection of high energy MSPs is almost entirely confined to galactic disk. The MSPs in the galactic disk have very different characteristics compared to the MSPs in globular clusters. Taken together, these facts suggest that the MSPs in globular clusters are likely to follow somewhat different evolutionary paths compared to the MSPs in galactic disk. Please visit our poster for details.